For your starter task today, you had three statements, three things to have a look at and think about whether they were true or not. Now, we're going to talk through those just to frame some of the important ideas in this lesson. So the first one here, we had every trig equation has exactly two solutions. So up until now, and particularly last week, we're solving things like sine x equals, say, a half. When we solved that, that's an exact value one. I picked that to be nice. We got x equals 30 degrees or 150 degrees. But there is an important thing to note, and that is that we were solving that equation for 0 is less than x is less than 360 degrees. So in this range, there are exactly two solutions. However, if we go to the graph of sine x, we can see that, okay, that's up to 360, and there were two solutions, one there and one there. But if we keep that graph going, well, we get another solution here and another solution here. You could keep that graph going again, you would get another solution and another solution. So actually, and it seems like a bit of a remarkable statement to make, but there are actually an infinite number of solutions to this equation. If we just quickly look at our values, first one's 360, double that, so we've had another wiggle of our graph by 720. Our next one, we've had another wiggle of our graph along here at 1080. So every time our graph wiggles, we get another two solutions to our equation. So between 0 and 360, most trig equations will have two solutions. I say most because there is one. If I let sine x equal 1, we'd only have one solution. If I let it equal 0, we'd have three solutions. So it's a few counterexamples in there, but most trig equations have two solutions between 0 and 360. But if we extend that range, we're going to get more solutions. That is going to be the focus of task 1 today. Statement number 2 that I gave you is also going to be really helpful. Now, if we look at our curve, what's happening here at 0 is also what's happening along here at 360. As we go along, the same thing happens. Our curve goes up from 360 to this point. So if this is 90, then this one along here is 360 add 90. So that is 450 degrees. So at 450 degrees, the same thing is happening at 90. Keep going, come along to 180 here. Then the same thing is happening 360 degrees later because we've done a full curve there, and then we start doing exactly the same thing again. So along here at 540 degrees, which is 360 add 180, the same thing is going on. So yes, this statement here is true, and that is going to be a really, really important idea, that we can just add 360 to an angle, it will still solve the same trig equation. That is a key idea that we're going to work on. Now, there's two extra things I'm going to say about that. The first one, if we have our cast diagram, like we had before, if I've got some angle over here, well, in some very technical sense, that angle there is exactly the same as that angle there, and then adding another full turn on. So if I do this little angle here, that's the same as doing that angle plus an additional full turn. I guess you can think of it, if you're standing and you turn yourself through maybe 30 degrees, and then you do a full turn, you'll be back still facing that same direction you were after you turned just 30 degrees. There is obviously an equivalent version of this in radians, because this is in degrees. So we could also write that sine of x equals sine of x plus 2 pi, and that's true in radians. So this is our degrees version, this is our radians version. And it's also worth mentioning, it doesn't matter whether we're working with cos, sine, or tan. So we can also have cos of x is the same as cos of x plus 360, or the equivalent 2 pi version, and tan of x equals tan of x plus 360. So whichever trig function you're working with, it repeats every 360 degrees. Now that's going to combine with this top fact here to give us our extra solution. So if we can find all our solutions between 0 and 360, then we can find extra solutions along here by just adding 360 to get our next one, adding 360 to get our next one. And then if you had these two, if you add 360, you get to this one along here, add 360, you get to this one along here. So we can find more and more solutions by adding 360 degrees or 2 pi to the solutions that we already have. We'll do examples of that in a minute, but that's one of our key ideas. The final statement here, I'm not going to spend a whole lot of time on, but it's good to think about. The answer is no, these two statements are not the same in any way. All I'm going to say, and I'm going to get you to think a little bit more about this in the starter to the second task, but think graph transformations. Remember, if we multiply a function by 3, that is taking that function, so if this is my sine x curve, and multiplying a function by 3 stretched it out in the y direction. So that's going to get us something that looks a lot more like that. On the other hand, multiplying the x value by 3 meant that we get 3 times more things happening. So if this is my sine function again, this is actually multiplying by 3 is a squash by 3 in the x direction. So we're going to get 1, 2, 3 repeats of my sine graph. And it's not perfectly drawn, sorry. 3 repeats of my sine graph in 360 degrees. So you get one little curve every 120. So no, these two things are not the same as each other. As I say, don't worry too much about that last one. We are going to come back to it. It's going to be relevant in task 2, but I'm going to get you to do a little bit more thinking about that shortly. So on to some examples in the next video, and we will be looking at this with degrees and with radians. The key idea is about finding more than just the solutions between 0 and 360.